Alright guys, so yesterday we started talking about some review for a difference in means and the sampling distributions for a difference in means, but now let's actually perform a significance test. So this situation is based on whether we list calories on the menu or not. We've got a whole bunch of data and we want to, and this data is from Starbucks, and we want to find, is there convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than at a Starbucks without a labeled menu. All right, so here's something that's going to make our life a little bit easier. Usually in the state for a difference in means, especially with a situation like this, I tell you to write, okay, like if you're going to use abbreviations, you got to show me what abbreviations you're using. But you can in the question, like mark up the question. So for example, these first numbers, it's 30 receipts. So I'm going to label this is from the labeled. So I'm going to label this NL for labeled. And then I'm going to label the next one average. This is X bar L. And this is XL. Sorry, SL. And then the next set is from unlabeled. So I'm going to write this NU. And that's X bar U. And SU. So this way, the grader knows what I am talking about when I use these letters. All right. Of course, we always start off our significance test by defining our parameter. So in this case, these come from two different samples, which means we have a true difference. So our parameter is a true difference, and I'm going to abbreviate in this, but you should write the whole thing out. True difference in means. And we are looking for the mean. So in mean, average calorie. Oh my God. Hold on. Let me zoom in for a bit so I can write this a little bit neater. All right. In average, calories per receipt at Starbucks with labeled versus unlabeled menus. All right, our statistic is going to be X bar of the labels minus X bar of the non-labeled, so unlabeled. So that is, let's see what numbers we have. We have 225 and 265. So that's negative 40. Our hypotheses. So our hoe, remember, we're going to be using equals for our hoes. So our hoe should be mu labeled minus mu unlabeled is equal to 0 versus our ha. Now we're trying to show that the average calories with labeled menus is less than without. So that means labeled is less than without. So if we have mu L minus mu unlabeled, since labeled is smaller, then this should be less than 0. And our significance level, it's not mentioned, but if it's not mentioned, we use the 5% significance level. All right, let's look at our plan. Name of the procedure. So we had 2 samples in this one. We're taking the difference of the samples. So this is a 2-sample t-test. We got our conditions random. So let's see, was this a random sample or random assignment? Yes, it is a random sample, and we can see that right here, random sample. So random sample, oops. All right, 10%. Our sample sizes were 30 and 40. So 30 and 40 we can assume are less than 10% of all Starbucks receipts. Probably less than 10% of what they have in an hour, honestly. All right, and then normality. So let's check for our favorite one, CLT. We have the numbers 30 and 40. Can we use CLT? Yes, we can. 30 is less than or equal to 30. 40 is less than or equal to 30. So this is normal by CLT. And now we have our two options for our do corner over here. Remember, we can follow all of these, and if you want to, that's totally okay. I'm going to show both right here. Our mean, we always assume is what our null hypothesis says, because we always assume that to be true. So mu1 minus mu2 is 0. Standard deviation, remember this formula. We went over it yesterday, but it is in your reference sheet. It is our first standard deviation, so 100 squared over that sample size, which is 40, plus the second one, which was 75 squared over that sample size, which was 30. And we get 21.770. To get our t-score, we take the difference in means, which was negative 40, subtract the assumed difference, and divide by standard deviation, which gives us a test statistic of negative 1.837. Let me scroll up a little. For our picture, so that means we're almost 2 standard deviations below the mean. The mean, again, we assume is 0. So that means negative 40 is going to land right around here, and we want the less than. And if we want to find our p-value, we can use TCDF to make that a little easier. TCDF. Since we want to be less than 40, any big number less than 40. Oh, sorry, not less than 40. TCDF is with our t-scores, so but still less than negative 1.8375. So we could still use negative 9 million. Negative 1.837, and we need our degrees of freedom here. So we have 2 different sample sizes. Do you guys remember which sample size to use? I just realized I messed up our sample sizes. I need to switch these. This one is 30, this one is 40. There we go. But since we have 2 different sample sizes, you always want to go with the smaller one. So we get that smaller degree of freedom, which will be 29. And remember to label DF, lower, upper. This will equal, let's see, 0.0382. All right, or you have the other option of using your calculator. So if you're going to use your calculator, you're going to go to Stat, scroll over to Tests, and now this is not a t-test anymore. It is a 2-sample t-test. So you go to option number 4. 2-sample t-test, you're going to input your statistics because we do not have the specific data points. Our X bar 1, that was 225. S1 was 100. That first sample size was 30. Yes, 30. X bar, that is 265. Second standard deviation is 75. And our second sample size was 40. We want it to be less than. Now you see this, gotta choose the less than, hold on. Now you see this next thing says pooled. Do not worry about pooled. Skip that, well, make it sure it says no, so it's not affecting our test. And calculate. And you can see our p-value is 0.035, which is pretty close to that other p-value that we had, 0.035 versus 0.038. Now, it's small enough a difference that's not going to, like the graders are not going to care. So remember, if you're going to use your calculator, you copy down this entire screen and that will get you credit. Remember to copy down the title as well to sample t-test. All right, but because we have this p-value, since 0.0382, we are comparing to 0.05 up here. It is less than 0.05. What do? We reject the hoe. We do not have convincing evidence. I'm sorry, we do have convincing evidence. Evidence. Yes, evidence. That, and remember again, this is where you can basically copy the question. We do have convincing evidence, and basically this whole section that's been underlined in peach, I will underline it in red now. We have convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than that without. You can copy that into your conclusion. So I will draw an arrow here so I'm not wasting time in this video. But of course you will write it down. All right, so that is basically how you perform a significance test for a difference in means. You have two ways to do it now. Remember, for the big ideas, look at the picture on Google Classroom. Please make sure to complete your workshop and your textbook homework as well. Before ending this video, there's one thing I want to note. See how for the workshop you're given a list of data here. My recommendation is using your calculator. So when you go to your test, to sample z-test, use the data section and have the data already in your list 1 and list 2. So remember to put data into your list. You go to Stat Edit, and you can see I already have the data in, so that when I go to my test, oh no, what's going on? Quit. When I go to my test, scrolling over to test number 4, I can choose my data option because I don't need to calculate my mean or my standard deviation or anything now. I have my lists in. I go to, I believe for this test we wanted greater than. Remember, pooled, leave it as no. That's not something you're going to use. And calculate. And it will tell me my x bar 1, x bar 2, sx1, sx2. So this way, when you have straight data, the two sample t-test will be able to calculate that stuff for you and save you some time. All right, make sure you email me with any questions. Make sure you upload your homework, and we only have one lesson left to this unit, guys, and then we're gonna get into review. So yay, we're almost done with the new material, and hopefully remote learning will be a little bit easier after this. All right, guys, stay safe.